So for our second lesson today, we're going to start by looking at what's called the discriminant. The discriminant will just tell you, so the discriminant, first of all, is just a number. That number will tell you the number and types of solutions your graph would have. So our discriminant is just, if we take our quadratic formula and we take the part that's underneath the square root, the b squared minus 4ac, that part right there. If we take what's underneath our square root and we get 0, so we type all that in our calculator and we get 0, that tells us that we will have one real root. So we're going to get the square root of 0, that's going to equal 0. Anytime that happens, it means that if you were to graph it, your graph would cross, or touch in this case, your x-axis one time. That point right there. So without graphing it, I would know that the parabola would just touch the x-axis at the vertex. The most common case is you're going to get a value that is greater than 0. So it's going to be a positive number. If you get a positive number, so say you end up with the square root of 16 plus or minus 4, you would get 2 real roots. That just means your graph crosses your x-axis 2 times. And then the last one, if like that would be your 2 answers where it would cross the positive and the negative 4. Yeah, so that would be your 2 real roots. Like if you were just doing the discriminant like they do over here, you would just get your 12. And then the last case, if you end up with a negative number, so we would end up with a negative number, that means you have no real roots, but now we know if we would end up with the square root of -9, we would have plus or minus 3i. Because if I take positive 3i and multiply it by itself, or square it, I would end up with -9 underneath my square root. It's the same way with -3. So we don't normally say no real roots, we say 2 imaginary. So anytime you're asked to find your discriminant, you get a 0, you have 1 answer. Positive number, you have 2 real ones. If you get a negative, you get 2 imaginary. That means your graph's going to look like this bottom graph. It's not going to touch your x-axis at all, but you can get 2 imaginary solutions from your equation. So for some of your practice problems today, I'm going to give you an equation and I'm just going to ask you, what are the types of your solutions? You don't have to find the solutions. You just have to tell me if you have 1 real, 2 real, or 2 imaginaries. So to do that, all you've got to do is compute b squared minus 4ac. So a is 3, b is 11, and c is 10. So if I calculate b squared, so -11 squared minus 4 times a, which is 3, times c, which is 10. Want to point out it's important that you put this -11 in parentheses. That -11 in parentheses means you're taking -11 times -11, which is 121 positive. And then if you take -4 times 3 is -12 times 10 is -120. So when I simplify this, 121 minus 120 is 1. So then I'm asking myself, is 1 positive, negative, or 0? It's positive. So since it's positive, that tells me I have 2 real solutions. And that right there is my answer. So since I got a positive number when I computed the discriminant, I know that I have 2 real solutions. So then we're going to go to the next one. We're going to again calculate b squared minus 4ac. So 2 squared minus 4 times 8 times 8. Let's see, so 4. Oops. Yep. So 4 minus 256 gives me a value of negative 252. Since it's negative, I have 2 imaginary. So 2 imaginary solutions is the most common answer. We have no reals, but we do have 2 imaginaries. I think on your assignment, the next section asks you to find the value of the discriminant and then state the number and type of solutions. You would just circle the last name, like your number you got. So your number and then the number and type of solution would be. All right, so let's practice using our quadratic formula with complex numbers. So first thing we're going to do, make sure it's in standard form. 6x squared minus x plus 3 is in standard form. So a is 6, b is negative 1, and c is 3. So there's my a, b, and c. And then I'm jumping back into my quadratic formula. It's up here for us if we forget. So I first off need the opposite of b. So negative b means I need a positive 1 plus or minus the square root of. So I need b squared, so I'm going to take negative 1 squared minus 4 times a, which is 6, times c, which is 3, all divided by 2 times 2 times 6. So 2 times a. And again, we're going to type this highlighted section into our calculator. Everything else we're going to leave the same. So x equals 1 plus or minus the square root of negative 71 when I type that in my calculator, all divided by 12. So new thing happened here. Now we have a negative underneath our square root. Well, we learned earlier today, anytime you have a negative, you bring it out and you turn it into an I. So now we're going to have 1 plus or minus I. We're getting rid of that negative and bringing it out as an I. Square root of 71, which conveniently does not simplify, all divided by 12. That would be our final answer. So 71 does not simplify. All you've got to do is get rid of that negative, bring it out, and make it an I. Because the square root of negative 1 is an imaginary number. We get rid of that negative 1 and just make it an I. The next one, we have 6x squared equals negative 8 plus 8x. My suggestion, when you move this to standard form, I always want to keep this term positive. I don't want to move it, even though it would be less steps. I want to add 8 and subtract 8x. So add 8, subtract 8x. But when I write it, I want to make sure I'm writing in standard form. So 6x squared, your x squared always comes first. Then your linear term, whatever has x with it. So negative 8x or minus 8x comes next. And then the plus 8. And now it's going to equal 0 on the right side. So now that we've rewritten it, we can identify our coefficients a, b, and c, 6, negative 8, and positive 8. So going to our quadratic formula, x equals negative b. The opposite of negative 8 is positive 8. Oops. plus or minus the square root of b squared. B squared would be negative 8 squared minus 4 times a, which is 6, times c, which is 8. All divided by 2 times a, which is 6. Again, I always want you to show me this step on all of your tests and quizzes. I'm going to give you 1 point just for writing it down. You can screw up the rest of the problem and still get your 1 point for writing this down for me. Once you write this down, I want you to take your highlighted part and type it into your calculator. So when I type it in my calculator, I end up with the square root of negative 128. Well, I know, oops, part of my problem's going to involve an imaginary number. Putting that aside, I'm going to take 128 and I'm going to break it up into two numbers, the multiply to give me 128, but one of them must be a perfect square. So 64 times 2 is 128. So I'm going to take the square root of 64 is going to give me 8. So I'm going to have 8i because I got rid of the negative. Square root 2. I don't know what the square root of 2 is, so I'm going to leave it there. So this 8 plus or minus 8i square root 2 all divided by 8. Oh, I mean 12. I lied. Oops. That should be a 12. So then you're going to reduce, again, that 2 is protected by the square root. You can't reduce it. You're going to reduce the 8, and the 12. So 2 plus or minus 2i square root 2, if it'll fit, all divided by 3. So then this right here would be my final answer. Questions on this one. So they're very, very similar to what we did yesterday, except now when you get a negative number, you're just going to put an I out in front. You're just going to repeat what we did yesterday. When you get that negative underneath your square root, you're just going to put an I out front.